This is Honors Algebra 2 Pre-Calculus. We're doing section 9.5 in Pre-Calc, and we're going to do example 6. We're going to find the fourth term in the expansion of 2x plus y quantity to the seventh. So notice they didn't ask you to do the full expansion. They asked you to find the fourth term. There are a few ways to do this. I'm going to argue that the binomial theorem and pinpointing the term you want is smarter, right, than like writing out the whole expansion, because that seems like a weird choice, right? So let's think about what the term should look like, right? So the fourth term, right? So if you think about what these terms look like, right? The first term would be the 2x to the 7th, and then the next term would be 2x to the 6th, right? So the first term is 2x to the 7th. Meaning, term number 1 is the x power is 7 minus 0. Term number 2, the x power is 7 minus 1. Term number 3, the x power is 7 minus 2, right? And term number 4, the x power is going to be 7 minus 3. So what we're looking at here is we're looking at a blank 2x to the 7 minus 3, right? Y to the third, right? Because my y went from 0 to 1 to 2 to 3, right? And then that means that this box right here is going to be my n, which was 7, right? My n is always the power on the whole expression. Choose the r, which is the power on the y, on the back seat, right? So I need a 7 choose 3, right? But then I also need to recognize that not only is this x to the fourth power, but the 2 is also to the fourth power. So I'm going to use my calculator to do 7 choose 3. Now I already did 20 choose 3 a second ago, so I'm going to hit second enter like a lazy bum. So second enter. And I'm going to replace the 20 with a 7, because that seems easier. So 7 choose 3 is a 35, right? 7 choose 3 is a 35. So I'm going to get that this is 35 times the 2 to the fourth, which is a 16, times an x to the fourth, times a y to the third. And again, no one expects you to do 35 times 16 on your own. You're welcome to if you want, but you don't have to. So you get 560 x to the fourth, y to the third. Notice it wasn't worth writing the full expansion out. You could write the whole thing out and figure out which one's the fourth term, but it's not really worth it. So notice, though, that the fourth term had the y to the third, right? Because the first term has y to the 0. The second term has y to the second. The third term has y to the third. The fourth term would have, the second, said it backwards. First term has y to the 0. Second term has y to the first. Third term has y to the second. Fourth term has y to the third. Sorry, sometimes when it's not in front of me, I say it backwards. Cool.